In this video, we're going to dive into classes. Now, you're already familiar with classes based on the premise of working with monobehaviors. And again, monobehaviors allow us the ability to attach scripts to game objects. One of the great things about classes is it's a crucial element to what's called object-oriented programming, also known as OOP. In object-oriented programming, the premise is that you can create clean modular programs that are organized well. And classes allow us to do just that. Basically, you can break functionality into separate classes, and within those classes, you can have fields and methods related to individual features. And we do this so that it's easier to debug and it's easier to maintain, and you can create better modular software. So in this example here, I created a little demo where I can move around in my ship and I can fire. And you'll see here that I can just move around. I have some restraints so that I can't go all the way to the right, and likewise to the left. Now, with this example here, I put all of the functionality, minus from the laser behavior, into one class. And you'll see here we have two scripts. We have a laser.cs and a player.cs. The laser script is attached to a prefab, which is our laser, and that just fires up. And this is a great example of when to use monobehaviors. Monobehaviors are for behaviors. A laser has one job. It just shoots up, right? So when I fire, it goes up. That's a behavior. So it should be a monobehavior attached to a laser game object. Our player can move around. It has behaviors. That's when you use a monobehavior. Throughout this section, we're going to get into non-monobehavior classes and when to use them and how to use them. But let's take a look at this class here inside of our player. This is a typical C# class that inherits monobehavior so that I can attach the script to the player. Now, don't worry if you don't understand what the code is doing. That's not the important part. What is important here is that I'm not making use of proper object-oriented programming techniques. Right now I have a player class and I just shoved everything into my update method. That means that if anything is wrong in my program or if I experience a bug, I have to go digging through my update method to find out what was wrong. Now, right now, my update method is only 25 lines of code here, maybe 20 lines of code. And what we can eventually have, though, is typically 1,000+ lines of code in your game. Now, you should never have scripts that ideally get up to 1,000, and you should break them out into individual components and scripts. But what we can do to better adjust for this is if we want to keep this class as a general player behavior, I can organize it better. So some of the things that I could do is I could isolate the movement code and I can isolate the firing code. That way, when I have a bug that's related to movement, I know exactly where to look. And when I have a bug related to firing, I know exactly where to look. So to do this, we can basically create organizational methods. So here, I'm going to create a new method and we'll call it private void and we'll call it calculate movement. And within this calculate movement method, I can then basically take the update code that's relevant to movement and I can remove it from update and place it in here. Likewise, I can do the same thing for my firing code. So private void, let's say shoot. I'll take the relevant code related to shooting and I'll place it in here. All I have to do now in my update is call those methods, calculate movement and shoot. How much cleaner is my program now? If I ever encounter a bug related to shooting or calculating movement or movement in general, I know exactly where to look. I can go right to this function here and start debugging my program. This is the concept of object-oriented programming. It allows you to neatly organize your programs. Likewise, if we head on over to our laser here, our laser's behavior is so small, it just has one task. It's going to move up indefinitely, and then once it gets off the screen, we just destroy it. If we wanted to, you could even create a void method for this as well. You could say private void, and then we can call this movement. And this is the movement for the enemy or for the laser behavior. We'll take that and place it in here. Likewise, you want to call it an update, and you just initialize it. And that way we have a much cleaner environment. Any issues related to movement of our laser, we know exactly where to look. Now again, these are very simple examples, but imagine in a commercial ready game, you will have hundreds, if not thousands of lines of code, and you'll need to be able to optimize it in a way that it's easily maintainable.